Hi kids! Today we have a special guest helping us out. Say hello to Mr. Bill.
Hi kids! Stay in school!
Well, today I will show you how to solve a differential equation by a technique called separation of variables.
That sounds boring.
Silly Mr. Bill! This is actually very useful for growth and decay applications. Say, Mr. Bill, I thought you loved mathematics.
No, I hate it.
That's what I thought. Wait, what? Okay, sorry about that, kids. We're back.
Yes, and as I was saying, I love mathematics. Be sure to fill in your notes as we go.
Ah, good advice, Mr. Bill. Now, let's begin problem number 1. Okay, first step is to actually write this as dy dx equals 2x over y. Don't skip that part, because now you can actually do what's called SOV, separation of variables. Let's do it. Y can come up, and the 2x will get the dx. Now you actually have a problem you can integrate both sides on. So if I do that, I will get y squared over 2, technically plus c, equals 2x squared over 2 plus a different c. So why don't we, instead of having a c on both sides, forget about the one on the left and just keep the one on the right. Now, we have an initial condition for this problem. The initial condition was 0, 2. We need to make sure that this function goes through that data point. So, why don't we plug those in? 2 will go for y, and we'll wind up with 4 over 2 equals 0 in for x will give us c. So c is 2. Now our equation looks like that. So, what we want to do now is solve for y. So we can double everything. And we can take the square root. And some of you are going to forget, it's plus or minus. Right, Mr. Bill?
I was just about to say that.
Ah, Mr. Bill, I don't know if I believe you. Back to problem number 2. This one is actually very tricky.
It won't be tricky for me.
Of course it will trick you, Mr. Bill.
Did I ever tell you about this one time at Subway
Hush now, Mr. Bill. Okay. The first thing you're going to do is rewrite the problem as dy dx equals ky. Because we want to separate the variables again. SOV. If we do that, why don't we leave the k where it is? That's not a variable. We can bring the y over to the left. So the problem is going to look like this. Now we're set to integrate. So if we integrate both sides, remember 1 over y turns into natural log of y. And instead of plus c, I'll put it on the right. So when I do this one, just be careful, it's a little tricky. It's all based on x, and k is a number. So the integral will be kx plus c. Now, we need to solve this for y. So in order to remove the natural log, we are going to exponentiate both sides. By doing that, we'll remove the natural log and leave us with y equals. Now, here's the tricky step. What they usually do is they rewrite this by going backwards a step and turning it into a multiplication that led to kx plus c. Because remember, you add the variables when you multiply the bases. Now, if you look at this, this is a number. E to the c, you might as well call it just c. So, I'm going to put that one on front, and I have c e to the kx. That step always happens. So if you ever see this e to the something plus c, drop the c in front, and that's the way to do it. What do you think about that, Mr. Bill?
Actually, I don't really like it.
Welcome back to our final problem. It is very friendly, Mr. Bill, if you know how to solve it.
It looks mean.
No.
So when I was at Subway,
Not now, Mr. Bill. We have a problem to do. Let's see. The first thing we're going to do is we're going to rewrite this so that we begin to separate the variables, SOV again. This time we've got some x's and y's mixed up. So I am going to move this over here and him over there. And it's going to look like this. 1 over y dy equals 2x over this with a dx. Now we're ready to integrate. Just like last time, this side is going to become natural log of y plus c, which will go on the right. And this time we are going to need a u sub.
does that mean I come in?
No, Mr. Bill. That means I'm going to do a u sub, not a u sub, but a u sub, which looks like this. That'll tell me what my chain rule step is going to be. It looks like we can get away with integrating that because this will cancel that. And we really have the integral of 1 over u du. So let's do that. If we integrate 1 over u, we get natural log of u plus c, which a minute ago we said u, not you, Mr. Bill, but u was 1 plus x squared. We are getting close now. We need to get rid of those natural logs. Here we go. We're going to exponentiate both sides. By doing that, we will wind up with y equals, and do you remember what happens here with e to something with a plus c? It's going to drop in front, and we can actually look at it as this for a quick second, but I just wanted you to see it before I wipe it out. This is going to drop to the ground, and here's the end of our problem. And we're done. We now have solved the differential equation. Wasn't that fun, Mr. Bill?
Yeah!
Now that we're all done, Mr. Bill, what was this silly business about Subway?
Oh yeah! You'll never believe what happened to me!
Hey everybody, it's Mr. Bill at a Subway restaurant. Today we're gonna learn how to make bread! Yay! First we need some dough. Next, Chef Sluggo says to roll out the dough. It's gonna be mean to me! Runaway boulder! Runaway! Great idea, Mr. Bill. Flatbread.
It took Subway to make a great flatbread sandwich. New full-size and flavor-packed flatbread sandwiches, like the tempting chicken Florentine or the bold steak and bacon melt. Limited time, only at Subway.
Subway, eat fresh!